welcome to AP Chemistry. I'm Mrs. Crowley, and I'll be your AP Chemistry teacher this year. We have a lot to discuss, so let's jump right in. First, please note that this is your first podcast for the summer. I'm breaking this lesson down into 2 videos to make it a bit shorter. I hope everyone got my summer newsletters that I delivered to your homes. Please make sure your parents read it over. I also hope that everybody received the summer syllabus packet before you left for school. And if you lost that, you can still recover it. It's available online at our class website, www.crowleyscience.com. And it looks like this. So this is where you're going to find all your notes, podcasts, guided notes, and updated calendar. This will be your main source of all current information and assignments. It's going to be vital that you keep good record of what assignments are given and when they're due. On the first day back to school, we will review all the materials from your summer packet and the syllabus. You'll be given plenty of time to finish this assignment if you didn't get it done by the first day back. I will work with you individually if you need, and I'm always here to help you, so don't hesitate to ask for more time if you need it. And in case you didn't guess, this class is very different from your traditional lecture, notes, and lab type science class. Most lectures will be given through these vodcasts, and you'll need to complete them outside of normal class time. They range from 30 to 45 minutes in length, but you can't just jump right in. You're expected to read and or skim the chapter before you begin your lectures. So it's highly recommended, even by my previous students, that you take your own notes on the reading from the text in your own notebook. It makes these vodcasts faster because you won't have to pause and rewind nearly as often. These vodcasts can easily take you longer than an hour if you're not prepared at first. So schedule your time carefully. You'll also need a quiet zone, or what I like to call a nest, in order to study without distractions. This place should include access to maybe a computer in which you avoid social media like Facebook and Twitter and other outside distractions. So try to break up the assignment so that you're not doing it all at once. A good study practice is 25 minutes on, 5 minutes off, and during your off time, get up, stretch, exercise, maybe do a phone call to your friends. But cramming or waiting until the last minute, especially at night, to do these assignments is a huge mistake. So schedule that time very carefully. And remember, skipping these videos or not doing your guided notes is like skipping a class or a lecture. Don't do it. Keep track of when assignments are due and don't wait until the last minute to do them. I often post vodcasts very early so that you can maybe get ahead, maybe on the weekends or whenever you have available time. I know you guys are very busy. So finally, I would like to talk about another amazing resource that we are going to be using this year, and it's called Flynn Test Prep. I'll be giving each of you an access code to help you review basic chemistry concepts. Later in the year, however, you will be gaining access to more in-depth topics, more AP-specific topics. But for now, it'll make a great review for those of you who need a little review on some of the topics that you may have forgotten from honors chemistry. But trust me, you'll catch up quickly. All right, let's discuss some resources I need you to have on the first day of class. First up, you're going to need a carbonless lab notebook. I recommend that you get at least 100 pages. They offer some that are bigger and smaller, but this is what most of my students had last year, and depending on how big you write, you may find yourself needing to purchase a second one by the end of the school year. All right, some students love to buy their own lab coats, which is perfectly fine. I don't like the lab aprons that I have in my classroom, but they're always available to you if you need them. The reason why I don't like them is because they have an open back where they tie. So if you do decide to purchase your own lab apron, just make sure that it goes down, that it's long sleeved and it goes down to your knees. Some students also love to get their own comfortable lab goggles. I would prefer that you wait to purchase these until I can show you exactly what they need to look like, because they have to have some very specific specifications. All right, the next thing that you're going to need is a calculator. It must be scientific with a log, anti-log, square root, and exponent. If you're also planning to go into calculus at some point, I would recommend that you just break the bank and get yourself a really good TI graphing calculator. There are certain advantages to purchasing a graphing calculator for AP Chemistry. We sometimes have to do a quadratic solve. So I can obviously show you how to do it the old-fashioned way, which takes a little bit of math and a little bit of, pencil, pen to paper type method, but it is much easier if you get a graphing calculator with a formula solver. All right, that just about does it. At this point, you're going to want to make sure that you have read chapters 1 and 2 before you proceed. You'll also want to download the guided notes that go along with this vodcast. And if you don't have a printer, please don't panic. Just do these questions on a separate sheet of paper. As always, if you have any questions, feel free to email me at any time, even if it's over the summer. All right, let's begin. Here are the topics that we are going to cover in this first vodcast. Rules for sig figs, review of dimensional analysis, density as a conversion factor, and some of the basics of the mole, which should be a review. I will be creating another vodcast that will jump us into chapter 2, but for now, let's begin. All right, everybody, let's begin. All right, so significant figures. I know my chemistry, baby, and you've got one significant figure. Haha, funny, funny. All right, let's begin. All right, so rules for calculating significant figures. Every non-zero, 1 through 9, is considered to be significant. So I give you a couple examples. The only digit that we really have to concern ourselves with is that pesky 0. Sometimes it counts, sometimes it doesn't count. And it can be difficult to figure out when it does. So there's only one rule for non-zeros, right? Well, we have about 4 others when we do have zeros. So those zeros are the hard ones. Let's take a look. So zeros appearing between non-zeros, kind of like the examples that you've got right here, they are significant as long as they have a sig fig on either side of them. It's kind of like how book ends, like on a shelf. Bookends will support the books in the middle, and that's basically what we have here. As long as you have sig figs on either side of those zeros, and it has to be on both sides, then those zeros in between have magically become significant. All right, zeros on the left in the front of a number, and you're like, when will we ever have zeros in the front? We only see zeros in the front when we have tiny numbers like decimals. So zeros in the front don't count. That's the rule. Zeros in the front don't count because we can eliminate them whenever we use scientific notation. So as you can see in these bottom 3 examples right here, sorry, these guys right here with the 10 to the negative 3, those last 3, sorry, that doesn't look like scientific notation. I gotta fix that. But anyway, you can eliminate those zeros by placing the value of the number into scientific notation. So remember, zeros in the front don't count. All right, here we go. Zeros at the end of a number have to be to the right side of a decimal point in order to count. So they not only have to be at the end of the number, but they also have to be to the right of a decimal place. So just because you have a 0 at the end of the number doesn't necessarily make it significant. Let me show you what I mean. So if we have the value, I'm going to do an example down here. Let's say we have the value 10. In the value 10, the 1 in the front is significant because it's a non-zero. This 0 appearing at the end of the number, yeah, it's at the end, but do you see that 0 appearing after a decimal point? No, I don't either. So the value 10 actually only has 1 sig fig. But all I have to do to change that is to do this. Watch this. 10.0. The 1 is still significant because it's a non-zero. But the 0 at the end of the number appears after a decimal point now. Because we have placed it after the decimal point, it has magically become significant. So this 0 at the end is significant, the 1 in the front is significant, and what did we say about zeros appearing between 2 sig figs? They count as well. So we have magically jumped to 3 sig figs in this example. This example here only has 1. So I gave you another example here. You see the 125, if I say I weigh about 125 pounds, it sounds a bit like an approximation. But if I say I weigh 125.00 pounds, well, that adds some significance to the value. That means that that 125 pounds has become much more specific. So you see how when we have zeros at the end of a number and after a decimal, we have increased the amount of accuracy or precision in the measurement. Some values have an infinite number of significant figures. This is true when we have scientific definitions. For example, 1 meter is exactly equal to 100 centimeters. So I could add an infinite number of sig figs to both of those values. I could say 1.00000000000 meters is equal to 100.00000000000 centimeters. So you see how they have an infinite number of sig figs and they go on, their sig figs go on forever. So when we have a situation like that in any of our math that we do in chemistry, what we'll typically do is look at the actual number of sig figs provided in the problem itself. A general rule of thumb is however many sig figs you see in the problem is how many you should probably use for your definition. In my other example here, you see how I use the value pi. If you just round the value of pi, you can round it to just 3 sig figs by saying 3.14. But when you're using some of these more complicated problems in AP chemistry, you may find yourself needing more than just 3 values there. So sometimes it's helpful to actually look up some of these conversion factors or some of these definitions and just making sure that you're using the proper number of sig figs. All right, let's get some practice here. So let's determine the number of sig figs in each of these measurements. So starting with the idea that the only values, the only digits that you really have to worry about are those zeros. In this first example, you've got the 5, the 4, and the 6. So you know all of those are significant. And the thing that you have to remember is that zeros in the front don't count. All right, so this guy's got 3 sig figs. In the next example, the 1 and the 5 are good. The question is, what about those zeros in between? Do you remember the bookend rule? All right, anytime you have sig figs on either side of zeros, all right, and make sure you understand that you have to have a significant figure on the left and you have to have a significant figure on the right. And as long as you have that, all of the zeros in between become significant. So this guy's actually got 5 sig figs. In the next example, what you see is you've got the 1, the 6, the 5, and the 4. All of those are significant. The question is, what about the 0 at the end? Zeros at the end are only significant if they appear not only at the end of the number, but after a decimal. And this one does appear after a decimal, so guess what? It counts. This is actually 5 sig figs. In the next example, you know the 3, the 4, the 5, they're significant. What about the zeros in the front? Remember, zeros in the front don't count. But what about the 0 at the end of the value? Zeros at the end are only significant if they appear after a decimal. And this one does. So you've actually got 4 sig figs here. In the next example, you've got all these zeros in the front. Remember, zeros in the front don't count. So the only one that counts here is that 6. That is 1 sig fig. In our final example, we have the 1 and the 4. The question is, what about the 0 at the end? Yeah, the 0 is at the end of the number, but is it after a decimal point? No, it's not. So this is actually only 2 sig figs. All right, here's a little chemistry humor for you, because what we're going to show you next is how to round to a specific number of sig figs. So when we get these crazy long answers on our calculators, I want you to be able to round them to a specific number of sig figs. So in our first example, or in all of these, I want you to round to 4 sig figs. So let's take a look at that first one. What we're going to do is, what I'd like to do is I start from the left and I find the very first figure, significant figure that counts, and I count over to how many I need. So I know in this first example, I'm going to look at the 3, the 1, the 4, that's 3 sig figs. I need 4, so I'm going to count the 7. But what I'd like to do is double check that last value to see if I need to round it up. You see how next to him you have a 2? If that 2 was a 5 or higher, you would need to round the 7 up. But luckily we don't need to do that, so we should report our final answer here as 314.7 meters. In our second example, we have all those zeros in the front. Remember, zeros in the front don't count, so the first digit that matters to me is the 1. Let's count over 4 sig figs. 1, 2, 3, 4. So the last value here is the 5. Do you need to round the 5 up? No, you don't. So let's get that 0, 0 in the front. You can't get rid of those because they're kind of like placeholders. And then we're going to go 1, 0, 0, 5. Now you can report your answer like this, or you can choose to put this into scientific notation, which would be perfectly fine. If we want to round this, this would be, or if we want to get the same number of sig figs, you have to go 1.005 times 10 to the negative third, and that would be meters. Either of those answers are perfectly fine. All right, in our next example, we still need to get 4 sig figs. So start on the left, 1, 2, 3, 4. Do you need to round the 6 up? Oh my goodness, you do. You've got a 9 next to him. So I'm going to round this to 3, 4, 5, and then I'm going to change that 6 to a 7. Now, you'll notice that the original value was about 3.4 million. Now, if I just stop right here and I report my answers 3,457, I have lost a ton of value. Well, you know you need 4 sig figs. The question is, if I add 3 zeros to the end of this value, am I adding any sig figs at all here? The answer is no. Those zeros at the end are, yeah, they're at the end, but they're not after a decimal point, so I have not added any sig figs here. Now, if I want to change this value into scientific notation, which I could do, I would have to be really careful because you see how I'm adding a decimal point now. I would only want to do that. You see how it's 1, 2, 3, 4 sig figs. Now, if I stick a 0 after that 7, that would actually increase it not to 4 sig figs, that would be 5 sig figs. So if I put a 0 after that 7, that would be wrong. You don't want to do that. So I would stop right here and go times 10 to the, let's see, that would be to the 6th power. And that would be meters. Meters. All right, let's look at this last one. It requires a little bit of creativity. You still need to have 4 sig figs. Now, if I just go like this, 1, 2, like that, how many sig figs is that? You see the zeros? They're at the end of the value of the number, but they're not appearing after a decimal point. I can change that. Ta-da! Do you see how I just changed it to 4 sig figs? Now, in order to get the proper value, I can use scientific notation. All right, so I can change that to times 10 to the 7th, and I've maintained the value of the original number that was given. Okay. All right, when we do math on our calculators, we need to be able to follow 2 separate rules depending on what kind of math we're doing. So if you're ever multiplying or dividing, you want to reduce to the least number of sig figs. But if you're ever adding or subtracting in the problem, you want the least number of decimal places. Now, if you find yourself confused and you're doing actually both multiplying, dividing, adding, and subtracting all at the same time, you need to make sure that you're always following the general rule of the least number of sig figs in the problem. So let's take a look at a couple examples here. So, for example, if you were to multiply 7.705 by 5.4 on your calculator, the calculator would give you the answer 41.607. Now, you need to look at the original problem to determine how many sig figs you need to round to. In this first value, you have 4 sig figs. In the second value, you only have 2. So you need to use the least number of sig figs in your final answer, which is 2. So 1, 2, always check, do you need to round that last value that you underlined? And this time you do because you have a 6. So your final answer should be reported as 42. Now, when you add or subtract, the rule has changed. This time, we're not worried about sig figs. We're actually worried about decimal places. So in this example, you'll see that you actually have 3 different values. This first one has 2 decimals, this one has 1, and this one has 2. When you add them up on your calculator, your answer will be 21.66. But as you can see, this value right here only has 1 value after the decimal place. That means you're going to need to round that so that you only have 1 decimal. So here's my first decimal, and you always do the same thing that you were doing before. You always check to see if you need to round up. And this time you do. So your final answer should be reported as 21.7. Okay, we're going to just kind of move forward and start talking a little bit about the metric system. These are some of the prefixes that I'm sure you guys are used to in all of your science classes. This is that King Henry thing, right? Kilo, hecto, deca, deci, centi, milli. Those are the ones I'm expecting everybody to kind of have memorized. But I think we should probably take it one step further. I don't know if you've ever seen these before. And I apologize, I couldn't figure out how to do my superscripts over here, but this should be 10 to the 6th power to the negative 6th power. This should be 10 to the negative 9 power, and this guy right here needs to be 10 to the negative 12. But anyway, so after milli, I want you guys to think even smaller. I'm expecting you guys to know what micro, nano, and pico is. So memorize those powers of 10.